Welcome once again to our commerce classroom. In this session, we will discuss about step method. We know step method is the second method we used in secondary distribution. For reapportionment of overheads, we have three methods: direct redistribution method, step method, and reciprocal method. In direct redistribution method, we know our service departments provides services only to production departments. Service provided by one service department to another service department, we ignore it. We doesn't consider services provided by one service department to another service department. But when we come to this second method, step method, we consider the services provided by one service department to another service department, but doesn't consider the services get back by one service department from another service department. In our previous example, A and B, two service departments. A can give service to B, but A doesn't receive back any service from B. That is what the assumption behind this step method. Then, when we solve a problem, one thing we have to take care is this: we have to arrange service departments in the order of their service providing capacity. I mean, we take those service department which serves the maximum number of other departments, and then second chance given to the second service department which has the capacity which serves the other departments maximum. This process continuing, and we ends with that service department which serves the least number of other departments. Then we are going directly to a problem. Our question is this: A Limited has three production departments and three service departments. Primary distribution summary January 2018 is given. Production departments A, B, C. A, primary distribution summary amount 40,000, B 36,000, C 30,000. Then we have three service departments: stores department, labor welfare, and then power. Stores primary distribution summary amount 18,000, labor welfare 14,000, then power 9,000. The following additional information is also available: A, B, C, stores, labor welfare, power. This is the order right here. Then number of employees: A 30, B 25, C 20, then stores 15, labor welfare 10, and then power also 10. Then value of stores requisitions: for A 16,000 rupees, then for B 12,000 rupees, then for C 8,000. Then for these stores and labor welfare, these two service departments, they have no value of stores requisition. And then our power department, their amount is 4,000. Then horsepower of machine: A 720, B 600, and then C 480. This stores department, labor welfare department, power department, they have no machinery there, so no information about this HP of machine. This is what our question. Then here we want to look to one thing. Firstly, in step method, which service department serves the maximum number of other departments? We know we have three service departments: stores department, labor welfare department, and power department. Then see here, our labor welfare department, we know they are dealing with employees. So this labor welfare department serves maximum number of other departments. Labor department actually serves the stores department, this power department, and then this production departments A, B, and C. So at the time of distribution of overheads of these service departments, we have to firstly consider this labor welfare. Then the second department which serves other departments maximum is, we know our stores department, when we look into the basis of apportionment, value or requisition 16,000, 12,000, 8,000, and then this power department, they have also requisitioned for stores. So second department which serves other departments maximum is our stores department. So we take stores department in second position, and then third position goes to power department. Power department serves only, we know this A, B and C, 720, 600, 480. This is a general thing we have to make clear before going to solve the problem. And then now we prepare our secondary distribution summary by using this step method. We have 6 columns. I draw now 6 columns. Then on first column I write the name of the department, and then on the second column I show the amount given by this primary distribution summary. Primary distribution summary is amount I show on these columns. Then these columns, these 4 columns I am provided for showing the distribution of overheads among different departments. Then as we know, we already discussed, we will start from our labor welfare department. The reason that labor welfare department serves the maximum number of other departments. Secondly, we write this stores department, and then thirdly we write this power department. Then we start from labor welfare. Labor welfare is a primary distribution summary. Amount is 14,000. 14,000, and then secondly we write this stores department. Stores department 18,000. Stores department is the second department which serves maximum number of other departments, and then thirdly we write the power department. Power department, that department is the service department which serves the least number of other departments. So amount is 9,000. Then we write the amounts of our production departments. So then production department, firstly A, then B, and then C. A's amount is 40,000. Then B's amount is 36,000, and then C's amount is 30,000. 30,000. Done. See what now I am going to do here. Our first department, first service department is labor welfare department. I am going to distribute this 40,000, the amount 40,000 among all these departments, the stores department, power department, then A, B and C, on the basis of on our equitable basis. Then see, firstly I am going to distribute this 14,000, so I provided a negative sign. Then in what proportion they distribute? We can distribute this 14,000 among these stores, power, A, B and C. Then see here, then labor welfare department, their basis for apportionment is, we know number of employees. Number of employees, here the number of employees A 30, then B 25, then C 20, then stores 15, then welfare 10, and then power 10. Then we distribute the labor welfare departments overheads among other departments. So we distribute it in the proportion of for A 30, for B 25, then for C, then stores department 15, and then power department on 10. Then firstly we start from our, firstly we distribute to our stores department. So we have to rearrange we rearrange these number of employees in the order of the departments. So we know our first department is the stores department. Then we can divide all these by 5. Then we get in the place of this 30, this figure 6, this is 5, and this figure is 4, and this figure is 3, and then this figure is 2. Then I am going to write these figures here. Then just see, then For this stores department, their proportion is this 3. Then for this power department, 2. Then A 6, B 5, and then 4. Just for our convenience, I am writing this figure here. 3, 2, 6, 5, 4. In this ratio, we will distribute the labor welfare expense among other departments. Firstly, 14,000. The total of this figure is 20. Then 14,000 divided by 20, that is equal to 700. Then 2,100. Then 1,400 for this power department, and then 4,200 for this production A, then 3,500 for this B, and then 2,800. See, now we distributed this 40,000 fully among the other departments. Then we write the total of this stores department. The total of these stores departments 18,000 plus 2,100, that comes to 20,100. Then now we distribute these 20,100 among other departments. 20,100. Okay. Then the basis of apportionment, we know the stores department serves the department A, B, C, and then our power department. On the basis of this value of stores. We have to rearrange the proportion here also. Then all these figures we can divide it by 4. Then we get 4:3:2, then 2, and then for this figure 1. Then we rearrange it 1, 4, 3, 2. 1, 4, 3, 2. Okay. Then we divide this 20,100 by the total of this figure 5, then 10. Then for our power department 2010. Then for our department A 8,040. Then for our department B 6,030. Then for our department C 4,020. 4,020, we check it. 4,020 plus 6,030 plus 8,040 plus 2,010, that comes to 20,100. So now we distributed the stores department overhead. It's total 20,100 among this power department or service department, and then production departments A, B, and C. Then now we are going to add the total of these power department. 9,000 plus 1,400 plus 2,010. 9,000 plus 1,400 plus 2,010, that comes to 12,410. 12,410. Here we are going to distribute the power power department, service department overhead total. This 12,410 among our 3 production departments. Then the basis for apportionment is HP of machine 720, 648. We take it as 72, 60, and 48. Then it's a total 72 plus 60 plus 48. That comes to 180. Then we distribute this 12,410 among our other production department, then this fraction comes to, the division comes to 68.94. 68.94, then 68.94 into first department 772, that is equal to 4,964 for A, 4,964 for A, then this 68.94 into this is 60, we get 4,136, 4,136, then we take the balance 4,964 plus 4,136 minus this 12,410, that's equal to this 3,310 to this production department C. Then now we are going to show the total overhead of our production departments. Then here the total comes to 40,000 plus 4,200 plus 8,040 plus 4,964, that comes to 40,000 plus 4,200 plus 8,040 plus 4,964, that's equal to 57,204. 57,204. 57,204. Then for our B, 36,000 plus 3,500 plus 6,030 plus 4,136. 36,000 plus 3,500 plus 6,030 plus 4,136, that's equal to 49,666. 49,666. Then for C, 30,000 plus, for C 30,000 plus 2,800 plus 4,020 plus 3,310, that is equal to 40,130. 40,130. Then we total it here 40,130, then 49,666 plus 57,204, that's equal to 1,47,000. 1,47,000. 1,47,000. I repeat what I did here. Firstly, we arrange the service departments in the order of the service providing. I mean the maximum number of other departments they serve. Labor department serves the maximum number of other departments, so we consider labor department firstly, then stores department secondly, and then power department thirdly. We wrote it here: labor, welfare, then stores and power. Then after that we write these production departments. Then firstly we write the primary distribution summary of all these departments. Then welfare 14,000, stores 18,000, power 9,000, and production production department A 40,000, then B 36, and then C 30,000. Then next stage what we did is this 14,000. This 14,000 we write here, and then distribute this 14,000 among stores department, power department, and other production departments. The reason is this welfare department gives services to all other departments. This stores, power, then A, B, and C. So distributed is 14,000 among stores, power, A, B, and C on an equitable basis. We already discussed about it. Then we got this 2,100, 1,400, 4,200, 3,500, and 2,800. Done. We totally here the stores department. Stores department is the second department which serves the maximum number of other departments. So we secondly take the stores. So this 18,000 plus 2,100, this 20,100. Then now we distribute the 20,100 among all other departments on an equitable basis. We already discussed this. Then our third department is service department, power department. And now the total of power department comes 9,000 plus 1,400 plus 2,010. That comes to 12,410. This power department serves only to the production department. So we distributed this 12,410 among production departments A, B and C. Then in our last column we totaled the total overheads of A 40,000, 4,200, then 8,040, then 4,964, total 57,204. Then B total comes to 49,666, and then for C that comes to 40,130. Then the total overhead 1,47,000. 1,47,000. Here also total 1,47,000. In this method we apportioned our overheads step by step. This method is also known as step ladder method. If you draw lines here, it seemed like a ladder. I think this session is clear for all of you. Our third method in secondary distribution is reciprocal services method. In our next session we will illustrate it. Till then, goodbye.